Kia ora, year 11 and 12. This is your favourite topic from the AS papers, vectors. So I've got two questions here. One looks really awful but actually is fine. And the second one is kind of a classic AS question, and it's using two of the big ideas that come up in AS for vectors, which is magnitude and also what it means for two vectors to be perpendicular, which comes down to the dot product or scalar product. So let's get into them. I think it's always a good idea if you draw a picture to go with questions like the first one. So here's the first question. Relative to some origin O, the position vectors of 2 points P and Q are given by P and Q respectively. So I'm going to write those like that. P with a little underline and Q with a wee underline. The point R is such that PQR is a straight line with Q the midpoint of PR. Find the position vector of R in terms of P and Q, simplifying your answer. Well, it all sounds horrible. Luckily, we can do a picture of it in 2 dimensions with a really bad graph. So here we go. Here comes the bad graph. Here's my origin O, and let's just whack 2 points on my graph here. So I've got P here, and I've got Q here. So we'll put on P and Q. The point R is such that PQR is a straight line with Q the midpoint of PR. So I've gone and done something silly, which has not left enough space, but this is all we've got. PQR is a straight line, and Q is the midpoint. So R is about out here, and we have to find the position vector of R in terms of P and Q, simplifying our answer. So the position vector P is this vector here. The position vector is always the one that goes from the origin to the point, and the position vector Q is this one here. So what is position vector R? Well, there's a few different ways to think about this. Where is my piece of paper? Let's just start from scratch. So what do I know? Well, we want to end up with the position vector OR. So little r is the vector from O to R. So how can I get there? Well, first I can go from O to P, and then I go from P to Q, and from P to Q again, because we know that this length and this length are the same. So we can find vector R as follows. It's position vector P plus 2 lots of the vector QP. But we know that that vector is the position vector of Q minus the position vector of P, right? Because that's how the vector from P to Q works, right? If I want to get from P to Q, suppose I had the numbers for those position vectors. Well, I might go, say I had 1, 4 for P, and suppose I had Q was equal to, I don't know, 6, 5, then the vector from P to Q is this, it's 6, 5 minus 1, 4, right? So you get really good at doing it with numbers, but sometimes it's a bit freaky when you have to go back to the abstract concepts, right? But all I'm saying here is that to get from the start, the origin, out to R, first of all, let's use a different colour highlighter to make it even messier. First of all, we go out here, and that's this bit here of P. And then because I know that Q is the midpoint, I know that to get to R I go once like that, and then I do the same thing again, and that will get me to R. So that's how come I've got 2 here, and I've got Q minus P here, because that's how I get from point P out to point Q. So what does that let me do? Well, that lets me write R as P plus 2Q minus 2P, and we can clean that up and we get R is equal to 2Q minus P, and that's my 3 marks. I think if you don't draw a picture for a question like this, most of you are quite likely to muck it up. I know that I probably would. Okay, so going on to part B, we get back to some real vectors with some numbers. Okay, now there are a couple of other ways you can do that question. Some of you watching will have done it in another way, and that's fine, but I don't want to take all day about this video because I'm getting a bit hungry. Okay, next vector, 6i plus aj plus bk has got a magnitude of 21, right, and it's perpendicular to this one here. So what we're going to do is write down the information we've got in the question, and we know that the magnitude of a vector is what we get from Pythagoras, so it's going to be 6 squared plus a squared plus b squared is equal to 21. I might as well square both sides right now and clean that up. So I get 36 plus a squared plus b squared is equal to 441. Cleaning it up further gives me a squared plus b squared is equal to 405. So that's fact 1. Now we're going to use the fact that these two vectors are perpendicular. I'll just get rid of this first. Right, so we've got two vectors. The first vector is 6ab, and the second vector is 3i plus 2j plus 2k, so we can write it like this. And we know that that equals 0 since they are perpendicular. Now, if you're wondering how I said that, it comes back to my definition of the angle between two vectors, which is given to me by this, that cos of theta is equal to the dot product of the two vectors scaled by their magnitudes. And in the case where theta is 90, we know, because we're good with our cosine curve, that cos of theta is equal to 0. So we get 0 is equal to a dot b, and we don't have to worry about this because I must have 0 in the numerator. Okay, so that was just a little bit of a brush up on the whole dot product idea. We don't need all of that here. We can quickly say that we know that if two vectors are perpendicular, their dot product is going to equal 0. So what we're going to get here is a linear equation in two variables. It's going to go like this. 18 plus 2a plus 2b is equal to 0. Dividing through, we get 9 plus a plus b is equal to 0. Now I've got a little pair of simultaneous equations. I've got this one and I've got this one. So we're going to do some substitution. Doesn't matter which way you go, but I'm going to write b is equal to negative a minus 9. Going back up to equation 1, you can finish it off from here. So now try substituting in and solving for a and b, being careful to get two combos for a and b. So a squared plus b squared equals 405. Just be really careful with your expansion. Plus I'm going to show you how I would expand that. I would take out the negative because I hate working with negative coefficients in quadratics. So we get a squared plus, and that negative 1 squared just disappears into a 1. This gives me a squared plus 18a plus 81 minus 405 equals 0. 2a squared plus 18a minus 324 is equal to 0. Common factor here of 2, so we'll divide through by that. A squared plus 9a minus 162 equals 0. And now we're going to factorize. Now if you're looking at that and having a brief freak out about how to factorize that, remember you can always go back to a factor tree. So let's see what we've got. 2 here and 81, and that's probably going to make you see the pattern pretty quickly if you're watching this video. So we've got 18 as a factor, and we've got 9 as a factor. So that's looking good. I want to have a gap of 9 here. So we're going to have a here and a here, and we'll do minus 18. Whoops, battery's dying. No, that's not right. Plus 18 minus 9. So we're going to generate two values for A, and then we're going to generate two values for B. Right, so hopefully some of you are still watching, because I reckon it's pretty easy to forget to answer the question properly. So we get A equals 9 and A equals negative 18. But B was equal to negative A minus 9. So that's equal to negative 18. Or here, B is equal to negative A, 18, minus 9, which is 9. So we've got two solutions. So AB is equal to 9, negative 18, or negative 18 and 9. Right, thanks for watching. If you are really rusty on vectors, make sure, AS guys, that you go through the chapter in your textbook and make sure that you've got down magnitude and dot product, because they are the two things that come up over and over again.